Welcome to TechPacks, your partner in advanced research and development. In this video, we will be presenting the details about one of the most demanding research projects, titled A Pioneering Fuzzy Inference System Model for Improving Lifespan of WSN. This research project can be extended further to publish a research paper in a reputed journal or used for your PhD or MTech thesis. So, if you are a researcher, PhD, or MTech research scholar working on a similar research project and need expert guidance to handle the complexities of research in this field, you're in the right place. Watch this video till the end to gain valuable insights into the project's objectives, methodology, and results. We'll also provide a demo of the code in action, showcasing its key features and functionalities. So, let's begin. Our professional researcher will now take the lead and guide you through the details. Here we go.
Hello friends, welcome to TechPacks Research and Innovation Services. Myself Deepak. Today I'm here to present you one of the recent research topic which is very much trending in the domain of Internet of Things, that is IoT. So this design protocol is for the sensor networks to communicate among the nodes to provide the successful data transmission with least power consumption. So before moving to the algorithm that we have designed, let's talk about that what we will cover into this video. In this video, initially we will discuss about in which application areas the design protocol can be implemented, where currently the sensor networks are popular and are in the real time. Then we will talk about whatever the code we have designed, how to execute it, what are the software requirements and the library requirements for it. Followed by this, we will discuss about that what are the current systems, what are the problems identified in them, and what proposed methodology is doing, and what we have done in this current research. Finally, an overview of the experimental results and findings will be given. So let's talk about the application areas. So sensor network is currently very much popular in the domain of the Internet of Things. So initially it was known as the wireless sensor networks. So Internet of Things is the domain under which the sensors are communicating by using the technology of the wireless sensor networks and sending the data to the remote location by the internet. So it is the collaboration of the internet as well as for the wireless sensor networks. The application areas where these are currently very much popular are like making the devices or areas as a smart one, like smart home, smart agriculture, education sector, smart transportation, e-health, and many other you can see on the screen. So in these areas, basically why it is smart, basically the locations are under the surveillance by using the different sensors. Those sensors can be of any category. Then on that behalf, the data is like transferred to the remote location through the network, which is providing us the access through the internet. So either it is wearable devices, healthcare, agriculture, everywhere the sensor based network are currently attaining so much interest. So schools, healthcare, industry, market, transportation, surveillance, they're the application domains of the sensor networks. Now let's talk about the code. So we will provide you this folder in order to run the code. So here, this is the folder basically. The whole code is written in the MATLAB. So you must have the MATLAB software with you. So you can use 2015 or the upper version to run the code. But make sure it should not be the trial one. It should be the full version of the MATLAB. I'm currently using 2019. So to run the code, you just need to copy this path, Control C, and then go to the MATLAB, and here you just need to paste it. Then press enter. When you will press enter, you can see whatever the code was there, you are able to see it in the current folder. So the files that you need to run is main code, and second is the comparison code. Rest files are the function files, those are called in the main file. So in order to run the code, you just need to select the file, then go to the run. Here when you will click on the run, you will be able to get the results. So we have done the whole code in the MATLAB, you can see, and then visualize the results in the graphical form. So I'm going to run this. In the meantime it is running, let's talk about the application, what currently the people are doing. So it will take some time to process. You can see it is running. These are the communication rounds. So the base paper that we have followed for the proposed methodology is like EHCR FCM, that is hierarchical clustering and routing using the fuzzy CMIN in the wireless sensor network. What they have done, this is a Springer publication. They have used the fuzzy c-mean for the clustering. Then they were doing the communication in the into a new scenario where they are not only sending the data from node to cluster head, but even they also introduced the concept of grid heads. So from the name grid, it is clear that they were initially dividing the network into the grids. Then the clusters are formed in those grids. Then the cluster heads are selected. For selecting the cluster head, they have considered two of the parameter. One is residual energy, another one is the Euclidean distance. So rest they have used the mathematical modeling for selecting the cluster head and the base station. So I just highlighted those equations here. The grid head selection, here you can see these are the equation they have used for the grid head selection, and then the cluster head selection. The problem that we identified is like in order to form the cluster, fuzzy c-mean is successful, but for selection of the grid heads or the cluster heads, initially the parameters are very less. Secondly, there should be some dynamic approach that can assist in forming the clusters and all, because here in the both scenarios the fuzzy c-mean is used to form the cluster. So the main contribution that we have made into this work is like we have updated the cluster formation strategy. We replace the fuzzy c-mean of the cluster formation, not for the grid one. For the cluster formation, we have introduced the concept of tree seed, a variant of tree seed uh, algorithm, TSA. The algorithm name is STSA, that is the advanced variant of TSA. So secondly, we have incremented the parameters, the dependency parameter for selection of the cluster head, and the decision is to be taken by the fuzzy logics, not the parameters directly. So in order to achieve the effective results, fuzzy logics will be the best decision model where the parameters are going to be increased. And secondly, cluster formation is done in such a way so that the equidistance among the network will be least. So by keeping these things into mind, we just developed the proposed system, and let's see whether we are able to achieve the better results or not in terms of the lifetime improvement of the battery of the sensor and all, right? So let's move to the code. So here, this is the code that we have designed. So you can have a look like what exactly we have done. After defining the initial parameters, what we did, we just created the fuzzy system. So fuzzy system is basically the system that we have designed for the decision making. So I'm just closing it here. This is the network that we have designed. This was the initial deployment of the nodes in the network. So you can see it is uniformly deployed. Then the grids are divided by using the FCM. So here, fuzzy design. So fuzzy design is basically for the parameters on which the cluster head will be selected. The parameter that we took for the cluster head selection are residual energy, remaining required energy for the communication, communication area to be covered, and sync distance. These are the four parameters that we consider that will give us the weightages. On the weightage base, then we have given the rules, different rules to identify that, and finally save the fuzzy decision model. So this fuzzy model is called here, and the created file is being taken into the decision model, which is further used to select the cluster head. Then FCM is applied to form the grids where 2.02, it means the two cluster heads, two grids will be there. So it will select the centers of the grid, and then on that we have the every node will be calculated with the distance with these centers, and the nodes those are nearer to which center will form a grid. Once the grids are formed, we found the nodes those are there in those particular scenarios. Later on, the previous algorithm was again forming the cluster using the FCM, fuzzy c-mean clustering, but we have used advanced variant of TSA, that is sign tree seed algorithm, to form the clusters. So this was giving us the cluster information that which nodes will be in the which cluster, and on that behalf we are extracting the information related to that. Further on, once the clusters are formed, we are calculating all the parameters those are required in order to select the cluster heads. But before that, grid head selection is to be done. So that we have followed the strategy that was followed by this paper. In the section number, you can read it is 4.1. So Dmax, Dmean is calculated, and on that behalf, FGH is calculated, and the node is selected as a grid head. So that what exactly we have did. Dmean and Dmax has been calculated into this scenario for the both things, and finally the grid had been selected. Then the communication round is being started, where the parameters are being calculated after selecting the grid heads. Then these factors for the clustered selection, all these factors have been passed to the fuzzy. So this is eval fizz, that is the evaluation of the fuzzy system, to which the fuzzy system that we have initiated at the initial stage. Here you can see the factor where we have read that fizz file that is created by us is used, and all the factors those were making the decision is passed to it as per the nodes. So fuzzy will give us the weightage value. So node with the highest weightage will be selected as the cluster. Same is done for the grid 2, and the final cluster heads are selected. Then the communication is being done where the nodes are sending data to their cluster to their grids, and grids to the sink. So this is how the whole communication is done, and finally we have evaluated the outcomes. So the results are compared with the traditional model also. So for the comparison, you need to run this particular file. It will take some time to execute, so I have already saved the results in order to show you the comparison. So this is the comparison code, to which when I'm running the code, you can see we can show that what exactly the proposed results achieved. So when I'm clicking on this, you can see the results will be demonstrated, the different parameters. So let's talk about the results that we have achieved. So one is the lifetime evaluation, in which the first node at, half node at, and last node at comparison is being done with the normal FCM, EHCR, FCM, which was the base paper, and the proposed technology. So you can see the first node that is at faster rate in our proposed one, but half node dead and last node dead are later on. It means the stability of the network is more. This is the factor of the alive nodes, where with respect to the communication rounds, the alive node curve is there. So you can see at the initial stage our proposed is getting down, but it gets stable for certain period and gives the higher lifetime. It is similar for the, this is the individual results achieved for the proposed methodology, and this is the live node curve for this. So you can also extend it to the further uses where further modifications are possible in order to achieve the results for the different scenarios like healthcare industry or wherever the protocol is to be designed. It is expected that this protocol will be better in terms of providing the better lifetime and better data transferability. So I hope you people like this video. For such more information or related information or the extension into this scenarios, you can contact us directly. Thank you. Thank you.
Thank you for watching this video. We hope you found it informative and engaging. For more information about this research project and to get our consultancy services, click the link in the description below. At TechPacks, we offer comprehensive support for researchers, PhD, and MTech students in the fields of engineering and ICT. Our services include selection of research topic, helping you choose the right topic tailored to your interests and the latest trends. Synopsis preparation, crafting a clear and concise synopsis with well-defined objectives. Coding assistance, providing expert help with writing and optimizing code in various tools and platforms. Research paper writing, assisting in drafting and editing research papers to meet the highest academic standards. Dissertation writing, offering complete support for your dissertation, ensuring consistency and quality. Plagiarism check and removal, ensuring your work is original and free from plagiarism with advanced detection tools. We also offer customization services to meet your specific project needs. Whether you require a modification of an existing project or a completely new application, our team of experts is here to help. Don't forget to like, share, and subscribe to our channel for more updates on cutting-edge research projects and expert advice. Thank you for choosing TechPacks. We look forward to collaborating with you on your research journey.